Alright, so part 2 of linear and angular speed, or really I'm going to treat this like part 1. It's actually the second video I made, but I want to talk about some things that are useful to know for solving any linear and angular speed problem. And I guess I kind of refer to this as my toolbox of useful knowledge, I guess. So I solve almost every single one of these problems using unit analysis. So it's nice if I know some tips that I can use to convert between things. So for example, I know that in one revolution of a circle there are 2 pi r, I'll say, units. Depending on the units there depend on what the radius is. So for example, if you want to go from RPMs, revolutions per minute, into a linear speed, you need to know how many revolutions there are in the units you're looking for. So for example, if you want miles per hour, you may start out with revolutions and convert into inches, and then go from inches to feet, feet to miles. So that's one little tip that's nice to know. Another one that I use a lot is I know that 1 radian is equivalent to 1 radius. So whatever the units are on the radius, I can convert between radians and inches or miles or feet or whatever the radius is given in. And that's useful also. And then the last one is I also know how to convert between revolutions and radians, because in 1 full revolution there are 2 pi radians, and we know that from the unit circle, or from any circle really. So these are the 3 main little tips that you can use when you're doing dimensional analysis or unit analysis in a linear or angular speed problem. Alright, so I'm going to leave those here, sort of, and work on a couple problems just to show you some examples. So for example, here I'm looking at number 73 on this worksheet, and I'll post a link to it. It says the diameter of each wheel of a bicycle is 26 inches. If you are traveling at a speed of 35 miles an hour on this bike, through how many revolutions per minute are the wheels turning? So we know that we're starting out with 35 miles per 1 hour, and our goal is to get this into revolutions per minute. Okay, so it's nice to have an idea of where you're headed with the problem. So again, they told us one thing that's really important here, that our radius is, they told us our diameter is 26 inches, therefore the radius would be 13 inches. Okay. So the first thing I want to do is, remember, I know from my little toolbox over here that I can convert between revolutions and the units I'm looking at if I know the circumference. So over here real quickly, I'm going to figure out what the circumference is. 2 times pi times the radius. The radius in this case is 13. That's inches. So my circumference would be 26 pi inches. So eventually I'm going to have to change from miles into revolutions, but first I need to change from revolutions into inches. So I need to get from miles to inches so I can do that. I know that in 1 mile there are 5,280 feet. In 1 foot there are 12 inches. And then I know that in 1 revolution there are 26 pi inches. Alright? So I'm going to erase some of this stuff down here. We've almost got our goal, which I'm going to leave that down here. We want it to be in revolutions per minute. So right now, if we check our units, we've got miles will cancel, feet will cancel, inches will cancel, and we're left with 35 times 5280 times 12 revolutions over 1 times 1 times 1 times 26 pi. Okay, so I should put 1 up there if I'm being consistent. And this is measured in hours. So I wanted revolutions per minute. I have revolutions per hour. So I know that, again, 1 hour is 60 minutes. Alright, so then the hours cancel, and I have revolutions per minute. So I just need to multiply this out and get a solution. I believe the answer should work out to be 452.490 revolutions per minute. Alright, so I don't have a calculator with me, so I can't really check to make sure, but I'm fairly confident that our math should work out correctly. So there's the example number 1. Alright, so let me look, I'll look at one more just so we can see another example. So that was going from linear speed into revolutions per minute, which is kind of like angular speed. Again, remember that this is another little tip. I guess we'll add it to this one over here. The angular speed is always measured in radians per time unit. It could be seconds, minutes, hours, depending on the problem. But radians has to be the units on top. Alright, so let me see if I can find one real quick here that we want to go the other direction. Okay, here's one. So number 81 here says that we want to find the speed of a river current. To approximate the speed of a current, a circular paddle wheel with radius 4 feet is lowered into the water. If the current causes the wheel to spin or to rotate at a speed of 10 revolutions per minute, what is the speed of current? And express your answer in miles per hour. So we know our goal is miles per hour, and we're told that it's rotating at 10 revolutions every 1 minute. And we also know that the radius of the wheel, R, is 4 feet. Alright, so we want to go from revolutions to miles. And again, I'm going to use that same trick again, I think. Actually, I'm going to show you another way that we could do the same trick pretty much. The first thing I'm going to do is change from revolutions to radians. And then I'm going to go from radians into feet, since I know that the radius is in feet. So again, in 1 revolution there are 2 pi radians. Technically we don't have to write the radians. I'm doing it just so I can cross stuff out. And then in 1 radian, that's equivalent to whatever the radius is. The radius in this case is 4 feet. There are 5,280 feet in 1 mile. So let's do a check here. Revolutions cancel, radians are gone, feet are gone. I'm left with 10 times 2 pi times 4 times 1 miles on top, and 1 times 1 times 1 times 5,280, and I have minutes on the bottom. So I wanted miles per hour, I'm in miles per minute. So the last thing I got to multiply by, another 60 minutes in 1 hour, so the minutes will cancel. So 10 times 2 pi times 4 times 60, all over 5,280. And that should work out to be approximately, this was number 81, 2.856 miles per hour. Oh, I guess you should, there you go. Now you can see what I wrote down there. Sorry. So miles per hour is what we wanted. We found that it's approximately 2.856. Again, you can see all the work here. Move this around for you. Alright, so there you go. Hopefully that was helpful. I pretty much solve every single problem the same way. I know with what I start, I want to find my radius, and I use, again, one of these little tips over here to help me convert. So they're all really, really useful. And you can use them to solve just about every single question in here. So hopefully that was beneficial. If you have any questions, feel free to send me a message, and I'll probably make one more video just for the fun of it. All right.